Hello everyone, welcome to my course Introduction to Physics. My name is Dr. Samad Maksutov. We will start. Introduction to Physics. Basically, I will give you some general informations, and of course this is not enough. We don't have enough time to explain all physics. So I will give just small part of general physics as an introduction. So let's start. So physics, this is a very big, very huge science, part of the science, so it's impossible to explain everything, to cover everything, which is obvious. So we will try to make it simple, and we will try to explain everything as simple as it possible. So in general, I use this kind of books for my courses. So for example, this is a Randall, author Randall Knight, Physics for Scientists and Engineers. I will be using this kind of books. This is just one of the methods that I will use. As you see, it's roughly how many pages? More than 1000 pages, 1300 approximately. And a similar book, Giancoli, same, around 1500 pages. This kind of books I will be using for my class, for my courses. Of course, there are so many different books, so many different materials. Physics is same in any book. So, what is the physics? As we said, physics is just part of the science, and everything starts with atoms, as you know. What is an atom? Atom is the smallest part of the matter. Matter. What is the matter? As you know, we are made of matter. Yes. Cell phone, matter. Solid, water is matter. Gas, air, everything is matter basically. And all matters, solids, liquids, gas, they are made up of small, very tiny, let's say bricks, yes, and we call it atoms. In order to see the atom, of course, you need to magnify, you need to increase the size of the object 1 billion times approximately. You should increase, you need to magnify the object size, of course, by using very powerful microscopes, yes. 1 billion times, not million, 1 billion, 9 zeros. Only then you can see atoms. It's very, very small, very tiny, very small. This is physics, basically. Everything starts with atoms. Atoms are very small. Of course, it will take a very long time to explain atoms, but it's very, very small. We can die, you can burn something, you can do anything with matter, with objects, with solids, with liquids, with gas. But atom, it will remain atom. Yes? Object can change its shape. It can change its state. It become liquid, it can become gas, but atom will remain. So basically, this is atom, I believe that it carries information about us. Yes, about everything, basically. And size is around 10 to the power of minus 8 centimeter, which means very, very small. Yes, and we call it, it has a special name, special unit for this size, and we call it angstrom. 1 angstrom. Atom. size is very small, and but it's very powerful actually. Yes, you know what is a nuclear explosion, atomic bomb. And atomic bomb basically huge energy. Atom is releasing huge energy, so it's very tiny, very tiny small thing, but it carries huge energy, very big energy, very huge. It can explode and it can release such energy which is equivalent to the atomic bomb's energy. Yes, this is the atom. There are so many things to talk about atoms, but we will skip it. Now let's come to physics. There are so many chapters. The first chapter is about motion. Yes, concepts of motion. What is a motion? When something changes position from when it moves from one point to another point. This is a motion, basically. Yes? And this motion can be described in different ways in terms of physics theory, in terms of mathematics equation. You can explain it. You can also explain it in terms of graphs. There are so many ways. Now let's come to the types of the motions. Motion in one dimension, when a car or something vehicle moves only in one line, let's say. Yes, car moves straight without changing its direction. When you throw something upward, this is also motion in one dimension. It comes back straight. Yes, so this type of motion we say motion in one dimension. Then we have a motion in two dimension. When you throw stone into the air with angle, let's say 60 degree with horizontal, what will happen? It will have something this kind of shape, trajectory. So if you pay attention, horizontal distance is changing and height is also changing. So this kind of motion, we call it motion in two dimension. So basically this is a combination of motion in one dimension. You have two types of motion in one dimension. The first one is horizontal, second one is vertical, and when you combine it, it becomes motion in two dimension. This is just one example. For example, circular motion. Our Earth is rotating around the Sun, or Moon rotating around the Earth. So this is also motion in two dimension. Next chapter, next main chapter, forces. Force causes the motion. Yes. In kinematics, in motion, we don't ask why this object, this vehicle, gains this acceleration. We just accept it. Let's say acceleration equal to 1 meter per second square. We just accept it. In dynamics part, in chapter part, in force part, in chapter force, you can get answer for this question. Forces, because force is related to the acceleration, or force causes acceleration. Newton's law, yes, first law, second law, third law. So this chapter explains how force can cause accelerations. Newton's first law, second law, third law. And the next main chapter is about conservation law. Conservation law, energy conservation of energy, conservation of momentum. Energy is everything basically. For example, at the moment you are hearing my voice. It means there is a sound energy. Without sound energy, you cannot hear. Light energy. At the moment you are watching me. Yes, via smartphone, via a monitor, it doesn't matter. Light is coming out from this screen. It means there is a light energy. Otherwise, you cannot receive this light and you cannot see my image this video. Kinetic energy, potential energy, mechanical energies, electric energy, nuclear energy, chemical energy. There are so many types of energies. And here in this chapter, we will explain how this energies converts, transfers from one type to another type. Yes? From one type to another type. For example, chemical energy. When you eat something, when you eat apple, for example, you receive some calories. Calorie is energy. So in apple keeps energy in terms of chemical energy. When you eat it, it will be converted to the sound energy you speak, light energy, thermal energy. You run, it means you also gain kinetic energy, etc. Momentum. Momentum is also physical quantity which is related to the mass and the speed, velocity. When you multiply these two physical quantities, it will give you a new physical quantity, and we call it momentum. Sometimes we call it impulse, yes? Momentum, impulse. Momentum also conserves. Momentum also conserves. We will explain it with details later. Fluids. Fluid means liquids, yes? Water, pressure, oscillation, waves. Thermodynamics. What is the thermodynamics? Thermodynamics, basically, this is everything about gases. Yes? Gases, atoms, molecules, pressure, volume, temperature, everything about gases. First law, thermodynamics first law, this is the same energy for gases, let's say, yes, conservation of energy law for gases. Next main chapter is electricity, magnetism. Now, what is electricity? You know, when you have a conductor, or let's keep it simple, wire, yes, let's say wire. Wire is a solid which is made of atoms, and each atom has electrons, yes, rotating around the nucleus, and some free electrons can jump or can move from one atom to another atom. When they move from one atom to another atom, it will create electricity, electric current, let's say, yes. So this is what you will study: electric field, electric potential, energy, etc. Magnetism, how magnetic field can be created, AC current, DC current. Then optics. Optics is basically about light. What is a light? Actually, light is not matter. Yes, it's light doesn't need any matter to travel. This is also a very good chapter, interesting chapter, optics, and it's about geometric optics, geometrical optics, yes, about diffraction, about refraction, reflection. When when light comes and strikes a mirror or shiny surface, it will change its direction. Or when light passes to the different medium, for example, from air to water, from air to glass, it will also change its direction. Yes, we call it a refraction. And the lenses, mirrors, plane mirrors, spherical mirror, lenses, converging, diverging lenses. Some of you wear glasses. This glass, why you wear glasses? Because it will change the direction of the light. Yes. Relativity and the quantum physics. This is one of the difficult chapters. So this is a general information about physics, and of course of course we will not study all these chapters, it's impossible. In this degree, in this year, we will start with kinematics, motion, basically kinematics, 1 dimension, 2 dimension, vectors. Then we will shift to the dynamics, Newton's law, forces, and we will try to keep it as simple as it possible. As simple as it possible, because physics is very huge, very big, and the laws today, we say this is a correct law, but tomorrow it can be wrong law. Yes, this is a science. Every day scientists, physicists investigating new things. People are coming with new theories, with new experiments. For example, we know that mass, what is a mass? Let's say cell phone. This cell phone has a mass, let's say 200 grams. What we can tell about mass of this cell phone? 200 grams, and for us this mass is constant. It remains same. This mass never changes. Yes, this is what we know. But some scientists say it's wrong. Mass will not be same always. When this phone moves with certain speed, velocity, mass will not be anymore 200 grams. So you see, it depends basically. Both people's is correct. I say mass constant, it never changes. Yes, it's correct for a certain range of velocities. But this is wrong for other different range of velocities. If this cell phone moves with a speed close to the light speed, mass will not be 200 grams anymore. Yes, so everything depends. Everything depends. Every day new theories, new experiments, new approaches. Yes, in physics basically we usually approximate. What does mean approximation? We just say, we assume no friction, we assume no resistance, we assume that mass constant, it never changes. Yes, but this is approximation. We are assuming. This is what we do to make it simple. But in real life, of course, everything is different. Yes, when you do experiments, you need to. You cannot ignore. You cannot approximate. Experiment always gives you correct result. Experiment. Of course, if you do it very well. It can give sometimes wrong results, wrong values, of course. If you use wrong device, let's say, yes, if your device is broken, then of course it will give you wrong results. But when you do good experiment, it will always give you correct result, correct value, of course with some errors. Yes, with errors, and then we try to solve it by using theories, and at the end, theory and experiment, they should meet at some point, at one point. Their results should be same, of course in one with some errors, with small errors. If you have a very big gap between theory and experiment, it means something wrong with your theory or with your experiment. So you need to check it. Okay, thank you very much. We will continue next lesson, our physics lesson, with the chapter, with the first chapter, motions. We will study motions with you. See you. Thank you very much.